Let's go to page 829. This is lesson 12.5. This lesson is to find the volume of pyramids and cones. It says, recall the volume of the prism is base area times height, okay, where B is the area of the base and H is the height. In the figure at the right, you can see the volume of pyramid must be less than volume of a prism with the same base area and height. As suggested by activities on page 828, the volume of a pyramid is 1/3 the volume of the prism. Okay, so here are the theorems. So theorem 12.9, volume of the pyramid. The volume V of a pyramid is V equal to 1/3 base B times H. Where B is the area of the base and H is the height. And same way, the theorem 12.10, volume of a cone. The volume of a cone is V equal to 1/3 B times H. And since the base area of a cone is a circle, so it would be pi r squared. Okay? Again, it says where B is the area of the base, H is the height, and R is the radius of the base. Okay? So sum up with what we have on the handout. So if you look at the handout, so notice again, prism is volume is base area times height. A pyramid is 1/3. So if you notice that if it's straight up, you just have base area times the height. Okay, so see over here, you can compare that with these. Okay, so again, if a solid it just goes straight up like that, okay, then the base is base area times height, base area times height. Whereas if it's pointy top, okay, if it's a pointy top, it's 1/3. Okay, see that? It's 1/3, 1/3. Okay? Again, if you look at side by side, so when it's straight up, it's base area times height. If it's pointy top, like a pyramid or cone, it's 1/3. Okay? And same thing over here again, cylinder. Okay? Again, if it's straight up, it's base area times height. If it's a pointy top, like a cone, it's 1/3. Okay? So you can compare that. So it's very easy to remember if you have everything all together and you can make a comparison. Okay, so let's go and do some examples. So page 829, example 1A. It says find the volume of the solid. So you have this triangular solid. And it gives you this over here. So again, when it goes perpendicular down, that's your height. Okay? So this is 4, 6, and the height is 9 meters. Okay, so whenever you're looking for the volume, you can write down your formula. Volume equal to, it's a pointy top, so it'd be 1/3 base area times height. Okay, so let's go and do this. So 1/3. Now base area, okay, it's a triangle, and notice it's a right triangle. So if you were to kind of just look at the base only, so the base over here is 4 and 6. Okay. Okay, so the base triangle is 1/2 base times height. Okay, so that's that over here. And the height, make sure it's perpendicular height, okay, be 9. Okay. So volume equal to 36 meter cube. Okay, because this is meter, this is meter, this is meter. So it'd be meter cube. So make sure you have the label, okay, very important. Okay, let's do the example 1B. Okay, it's a cone. Now it doesn't matter if it's slanted or if it's right. If a right cone or oblique cone, doesn't matter. Okay, it will not affect the volume. So over here is 4.5 centimeter, and the radius is 2.2 centimeters. Okay. Okay, again, it's pointy top. So write down the formula. So if it's pointy top, it's 1/3 base area times height. So you go and substitute again. Always write down your formula, then you go and substitute afterward. So 1/3. Now, whenever you substitute, put in parentheses and brackets, you're using a grouping symbol. So base area is a circle, so it'd be pi r squared. Okay, so that's the formula for the circle. And the height of the cone is 4.5. So get your calculator. Okay, you can just multiply, so it'll be, you can use fractions, so 1/3 times, okay, pi times 2.2 squared, so 2.2 squared times 4.5, push equal. So volume would be about equal to 22.8. If you run it off to the two decimal place, would be 81, and again centimeter cube. Okay. Now the book use a wiggly line. That means approximately equal to, because we chop off some digits, right? But if you have it equal, that's fine. You don't have to be, you don't want to use the wiggly line. Okay, you don't have to use a wiggly line. This means approximately equal to, because we chop off some digits, right? That's what they use that. But if you just have equal, that's fine. Okay. Normally, to be technically accurate, equal means exact. Okay. But again, we're not going to be that nitpicky on that. Okay. Okay, let's go to example 2. Okay. It says, originally the pyramid has a height of 144 meters in volume. Okay, so this is a pyramid. Okay, and it gives you the height equal to 144 meters and the volume equal to 2,226,450 cubic meters. Okay, and it says find the side length of the square base. Okay, here is a square, right? Okay, and so you're looking for S. Okay. So again, write down all your information. Write down what's given and what you're looking for. Okay. Now, since this is a pyramid, so right away, first you write down the formula. Right, so equal to V equal to 1/3 base area times height. Okay, then after you substitute everything in here, so volume is given, so it'd be 2,226,450 equal to 1/3. Okay, now this is the base area. Now is a square, right? So it'd be S times S, right? That's a base area. Okay, times the height is given is 144. Okay. Okay, so what we can do is to solve this, right? Again, to solve for this, we have to move all this. So first, let's get rid of the 1/3. To get rid of 1/3, to undo 1/3, you have to multiply by 3. Okay, so multiply by 3, so that this will cancel out. Okay, then after that, to get rid of these, you need to divide by 144. So divide by 144. So this will cancel out. Okay? So now the S squared will equal to, you have to use calculator, work it out. Okay, so 3 times 2,226,450 and divided by 144. Okay, so it would be 46384.375. Okay, now to find the S, you take the square root. Now, since you have this number already, don't clear. Okay, just use this number. Do not clear. You just go the square root of the answer that we got from before. Okay, push equal. So it'd be 215, and there's how many decimal place? It doesn't say. So in the book, it run it off to the nearest meter. So that's what we're gonna do. Okay. So again, remember to have your label, the meter. Okay, let's go to example 3. Okay, example 3 says to use trigonometry to find the volume of cone. Okay, so it says find the volume of the right cone. So you want to draw a picture that's big enough so that you have room to label your numbers. Okay, so this is 16 feet, and this is 65 degrees. Okay, so again, to find the volume, right away you write down the formula. So volume equal to 1/3 base area times height. Okay, then after that you substitute whatever you know, and you go from there. So base area is going to be pi. Now, you don't know r, so we're going to leave it blank for now. So again, base area is pi r squared. Okay, the h, we know h is 16. So again, you write down your formula, you substitute whatever you know, and whatever is missing, you have to go off to the side and look for it. Okay, so to look for r, again, we're going to use the trigonometry. Okay, there's the angle over here. So this is the tangent function. When the two legs are given, is tangent. So tangent of 65 degrees, so tangent of this angle equal to opposite over adjacent, equal to 16 over r. Okay, so you got to know your trigonometry. So again, tangent of this is opposite over adjacent, so you cross multiply, and you divide. So r equal to 16 over tangent of 65 degrees. So get your calculator. So 16 divided by tangent of 65 degrees. Okay, so r equal to 7.461. Okay, again, I'm going to carry extra digit, and I'm going to run it off when for the final answer. So 7.401. Okay, now to figure out this part, okay, since I already have this number already, do not clear. Okay, I'm just going to square that and multiply all these things out. Okay, so since I already have this number, I'm going to just use that so it be more accurate. So I'm going to square that times by 16. Again, I'm using finger to keep track. Then I'm going to multiply by pi. Then I'm going to divide by 3. And push equal. Then from here, I'm going to run it off to second place, 2 places. So volume equal to 932.68 cubic feet. Okay. Now, if you notice in the book, this is off by a little bit, so don't worry, okay? Because this is what's matter. Because this is off by so little, it does not matter. In the book, it's 932.45. Now, because we use exact numbers, so that's why it's off a little bit. But again, don't worry about it. Okay, here's the main thing, right? As long as you're fairly close, okay, then you're fine. Okay, let's go to example 4. So page 831, example 4. Okay, this one, find the volume of a composite solid. Composite solid means you're combining more than one shape, right? So basically you have a pyramid on top. Okay, I'm going to put this up here. So basically you have a pyramid on top of a cube, okay? And so the height over here, this tells you that the height equal to 6 meters, and each side is 6 meters. Okay, so first, again, let's do the strategy. Okay, so the volume will equal to the cube plus the pyramid. Okay, and you can put numbers in there if you want to. So each side is 6. So the volume for the cube, again, you can use the base area times height. That's fine. Or you can just use side times side times side, right? So this will equal to 6 to the 3 power. And this one is giving. Okay, so everything is giving. So the pyramid would be, so the volume equal to the x cubed plus 1/3 base area times height. So let's go and write down the formula. Okay, so it'd be 6 to the 3 power plus 1/3. The base area is 6 times 6, right? Again, whatever you substitute, put in parentheses. Okay, so this is the base area. The base is a square, so it'd be 6 times 6, and times by height. Okay, so now you go and use your calculator and work everything out. Okay, so 6 to the 3 power plus 1/3 times 6 times 6 times 6 equal 288. And does have a label? Yes, so you have meter cube. Okay. So when things get complicated, go and break it down into small parts and just work it through. Okay. Okay, let's go to example 5. It says you are using funnel to measure the coarseness of a particular type of sand. It took 2.8 seconds of the sand to empty out of the funnel. Find the flow rate of the sand. Okay, it says in milliliters per second. So 1 milliliter, so it tells you 1 milliliter equal to 1 cubic centimeters. So basically you have a cone. Okay. So this is 4, and this is 6. Okay, so to find the rate, first we need to do is find the volume first. Okay, so volume of a cone is 1/3 base area times height. Again, always write down your formula, then you substitute. So the base area is pi r square times height. So let's go and figure it out. So 1/3 times pi times 4 square times 6 equal. So the volume is about 100.53 cubic centimeters. Okay. And this was also equal to 100.53 milliliters. Okay, so cubic centimeter equal to milliliters. Okay, now we're going to find the flow rate. Okay, so the rate will equal to the volume divided by time. Okay. And so this will equal to 100.53 milliliters divided by time, which is it's 2.8 seconds. So you can write down the labels. It helps you to kind of check see if you're doing it correctly or not. So the rate will equal to, again, I already have this number already, so I don't want to clear. Okay, I just use the number. Just want to divide by 2.8. So it will be 35.90 milliliters per second, right? Milliliter per second. Now again, number is off a little bit, but again, it's okay because depends on how you run it off. But overall, it's pretty close. As long as you within, maybe within, I would say 3% is fairly accurate. Okay. Okay. So again, the book had 36.07. But this is close enough. Okay.